Cross-country ski race. Like I said yesterday, you've probably all completed this. How many folk have finished it? Okay. I'm not sure whether this is tougher or not compared to the... I reckon they're both about the same. They're both got gnarly bits, and for me the movement of the flag was the trickiest bit, but we'll come to that in a minute or two. Now, if you've done things a different way, that's still fine. The customer won't care, as long as the game works and they can try and beat the high score or whatever, customer won't care. But I thought it was useful just to go through how I would do it, so that you can then think in terms of getting started on your own solution. Don't make the entire game all in one, because you won't be able to sustain. Maybe you can pull all-nighters and all that kind of stuff. Maybe you're young and fit enough to do that. I'm not, so I've given up on this. But yeah, do a chunk, have a planned sequence of deliverables, yeah, that's pretty much the same slide as you saw not 4 or 5 hours ago. So yeah, any ideas in terms of sequence? Yeah, well, this is what I did. Make a base sprite class. Now, load and save is an important component of the game. We want you to be able to actually get the game back to where it was before, so that you can press the pause button and then resume later on. So the storing behavior should go in fairly early, I reckon. It's very similar to the bank account, except that it isn't. The difference is that you don't store the texture, you probably don't store the width and height of the sprite. The only thing you're really fussed about is the position on the screen, because all the other stuff is set up for you by load content. So when you think about what happens, the game fires up, the program builds all the sprites and lobs them in the sprite array, of which more a little bit later. And having done that, we then start playing the game. If they hit the quit button, we can spin through the array of sprites and spit out their X and Y positions one after another. And you might find that if you just do that, and then when you recover it, you put them all back again, it will just work. The save behavior for your parent sprite class that just pops out the X and Y values is probably all you need. The game objects aren't particularly stateful, apart from the player who has a life counter, and that can be stored as part of the game and not part of the player anyway. And then of course there's a score you'll have to save too. But it's still important that you get that in early, because my experience has always been that retrofitting save behaviors is hard work. So put it in when you build it. Once you've got your sprite working, and make just a sprite that draws a texture on the screen, like my bouncing ball, which I had running a few seconds ago, although that isn't a sprite yet, we'll do that in a second. I then, just like with the ski lodge program, just like with the ski management thing, I then make the container. So now I'm going to make the playfield, and the playfield contains a list of all the sprites in the game. Does it have to be a dictionary? Nope, because we never have to find the sprite by name. In the case of the dictionary for the skier management thing, we have to find a particular competitor by his competitor number. In the case of this, no, all we'll ever do is spin through this list, so just make it a list and you'll be absolutely fine. Once you've got it working though, get the load and save behaviors working for that, and just like you could steal all the behaviors for the sprite, the skier management from the bank, do the same thing for the game. Once I've got my load and save working, then I put a skier sprite in, and what skier does is he extends the base sprite class and he provides an update behavior that lets me control the skier around the screen. And then having done that, I'll lob in the cheese and the snowball to the two classes that we have to put in there so you can find the cheese and avoid the snowballs. And then I do the hard thing. There are tons of different ways of making the flags work. And every time I sit down and think about it, I think of a new and better way of doing it. One of the sayings that I have with regard to development, I think I've made it once or twice before. To solve a problem properly, you have to go and live there. So effectively, you have to get yourself to the point where you're thinking about this thing, and you've got a really good handle on what you're trying to do. So if you're in the middle of a particularly boring bus journey, or driving down the motorway, or whatever, and you want to sort of get your back brain ticking along, just think about different ways in which you can solve the problem. My first version had a flag row sprite, which extends the sprite class, manages a row of 2 flags. I don't actually think you have to do that. I think there's actually ways of doing it better, where you just have a left flag and a right flag, and then you have a pair of those going, and you just basically put those on the screen, and the 2 flags don't need to know they're part of a row. They can just do their thing, which we'll talk about in a minute or two as well. But once I've done my flags, I'm going to do them, I then make the game states, so I can manage game over, and I can manage the demonstration bit, I can manage the high score. And after that, I'm done. Like we had this morning, there's a page for each of these. The sprite class contains a texture, which is going to be what gets drawn when the sprite is put on the screen, and a rectangle value, which contains the draw position. And the thing which I do, which is extremely useful, I use a vector to place the sprite on the screen. Do you know what that means? Are you okay with that? Storm of apathy. Right, I think there's actually some slides a bit further on about what the sprite class looks like. I think there are somewhere. But yeah, here we go. No, we haven't just got the behaviours. Yeah, that's my sprite. Yeah, fine. What I'll do is I'll actually just drop out of this now, and I'll go into Visual Studio, because you might find it useful. This is just the bouncing ball from one of the demos. This is the white ball that bounces. There he goes. It's quite pleasing to watch, but the problem with him is that we position him using a texture. Sorry, a rectangle, which means that we don't know where he is to any precision greater than integer value. So I can place him on pixel positions, but I can't place him anywhere else. And this can be a problem if you want your sprites to move slowly or precisely. So what I do is this. Let's make ourselves a class called sprite. Okay, and what will the sprite contain? Pardon? Yep, like that. Public texture 2D, and because I don't care in this context, I'm going to make all these guys public. What else has it got? Position, right. So I'm going to go for, this is the bit that's different. Sprite position. Okay, so I'll make that guy public as well. I'll actually use a semicolon. Yes, it's going well, Rob. Okay, what else do we need? Well, what I do, rectangle, is I give him a rectangle as well. So this is going to define where my sprite is, how big he is, and where he is on the screen's floating point precision. Is everybody okay so far? Say yes, Rob. Fantastic. Okay, so I can give him a constructor. I can't spell sprite, and I'll give it, I don't know, texture 2D, texture, and then rectangle. And what will I do with these? Well, I'll copy them So sprite texture equals texture, and then sprite rectangle. It's awful when you know what you want to type but you can't get your fingers to go fast enough. Right, okay, so that doesn't place him on the screen anywhere. Maybe we should give him a vector so we can put him somewhere also. So just as a starting position, I'll go ha. The reason why I'm doing this is I did this for all the bank people with the accounts and whatnot. So we might as well do it for sprites as well. Position. Oh. And then in here, I'll go. So, I think I may have spelled that wrong. Yeah, so what you do is you go in here, you hit F2, you press the function button, you hit F2, and then you go, okay, it's not very helpful, but I'll just go slap an N on the end of position there. Then I hit apply, bang, it fixes it. Right, okay, so, is everyone okay? Now, the sprite will have two behaviours. What are those two behaviours going to be? They're going to mirror what the game does. So, public virtual void update, and we'll pass it the game when we update it. And then in here I'll go public virtual void draw, and when we draw it we'll give it the sprite batch. Now, what does it mean if I've made it virtual? Is that so you can use it with VR applications? Fine. Monday night, we're all knackered, fair enough. What does it mean if it's virtual? I can override it, yes. Children can provide their own updates and draw behaviours. The way my programs work, this is just how Robert does it, but it works quite well for me too. When you call draw does two things. Draw does this. It goes sprite rectangle dot x equals sprite position dot x. Now this guy is floating point, okay? So we don't actually, that doesn't work too well because that's a floating point and that's an integer. So I go math dot round. Will this work? No, I'm going to get a decimal back, am I? Oh, drat you. Yeah, okay, so round it up or down or whatever, and then convert it into an int. Math.round just basically adds 0.5 to it and then truncates it. So that basically sorts out where the rectangle is going to go there. And then I'll do the same thing using the, oh, I can't do it. Why not? Copy, paste. I'll do the same thing with y. And then in here I'll go there. So that's that. And now I can go, having placed the rectangle where the vector thinks it is, I go sprite batch dot draw. And then I give it the texture, and I give it a rectangle, and we'll draw it. We'll draw it white so that it looks okay. Right, so that's my draw behavior. Everyone okay with that? Update does nothing. That's fine. Draw does all the heavy lifting to draw it. So now in here, let's go into load content, get ourselves a white dot, get rid of all this rubbish. Yeah, get rid of that. Oh no, actually I might use that, actually, Control Z. I'll bring that back from the dead in a minute. I can make sprites now, can't I? Let's make a sprite called ball. There he is. Okay, and so in here now, make a rectangle, got the texture, so now I can go ball equals new sprite, give it the ball texture, give it the ball rectangle, and then where should we put it? Vector 2. Vector 2 has a built-in place called 0, which is effectively 0, 0. That places in top left-hand corner. Are we okay with what I've just done? I've made thing. It's going to be a 30th the width of the screen. It's going to be blah, blah, blah. So now in here, all this stuff, we'll just sort of leave this for now. I'll comment this out because it's in the wrong place. No, I'll delete it. I don't care. This all dies. Bang. Okay, so update does nothing. Draw. Well, what we do now, we start drawing and then we get the ball to draw itself. And this is the thing that I want you to understand. I don't draw the ball draws itself. Oh, little s. Thank you. So if I run this, what should we see? We should see a white dot in the top left-hand corner of the screen because that's where I've put you. Okay? Is everyone all right with that? It's a bit boring, but it's there. Okay, so that's my base sprite. Okay? And it doesn't do much, but I don't care. What do we do next? Well, I quite like a whole bunch of those. Well, let's give him some movement. Well, no, let's. There's all kinds of things directions we can go in at this point, but let's make a whole bunch of sprites because that's the next thing I'd really like to do, and then we'll go on from there and just have a little fiddle. How do I make? Well, let's go back to my slide deck. Let's go back to where I was. Because I've just done step 1. Create a base sprite class. There you go. It's got the draw and update methods, which I'm overriding. That's all good. Okay with that? How off the time? Yeah, we'll be right. I'm not doing load and save. That's your job. I've got to give you something to do. But you can see that just copy the values and the vector out into a file and bring them back. Absolutely fine. Play field, right. What's the play field? It's got all the sprites in it. How does this work? Let me show you. So in here, I make myself a list of sprites, which I'm going to call play field equals new this sprite. There they are. Okay, isn't that nice? And so now when I make my ball, I go play field dot add ball. Put the ball on the play field and then go through here and change this program here. So now I go for each of the sprites in the play field. Ask it to draw itself. And if you get this, you're made, you're golden, you're sorted, you're happy. I'm going to have a whole bunch of sprites on the screen. They're all going to behave in a way that's specific to them. They're all going to have draw behaviors. If I want to change the draw behaviors so that some of my sprites have got shadows, make them look 3D, or draw things twice or whatever, or I put other bits and pieces in, I can do that by overriding the draw behavior. As far as my game is concerned, all it does is spin through all the sprites in the game and draws them. So if I run this now, it looks exactly the same. Huh, that was boring. Right, let's do this. See this code here? Well, let's put that in a loop. for int I equals 0, I less than 100, I equals I plus 1. Good, and then go back here and just do this. And the only thing which I'll do that's different is at the moment I'm placing them all at vector 2.0, I'll actually make a new vector and put them somewhere else. New vector 2, I, comma, I. Make it a comma and it'll work a lot better. Okay, close off that. So now I'm making 100 sprites and I'm putting them all at different positions ever so slightly. Run the program, what happens now? Well, I get 100 balls and they're all sort of on top of each other. Now, you're wondering how you're going to get a whole bunch of flags into your game along with the player and the cheese and the snowballs. This is how you do it. Okay? Does that kind of make sense? That's how the playfield works. And the rinky-dinky thing is that, my goodness, that's remarkably like the ski contestant management thing where you have a skier and then you have a container which contains all the skiers. It's remarkably similar. It's the same fundamental. So I've got all the balls there, they're running, and at the moment they're not doing much, but that's all absolutely fine. What I'll do is I'll actually stop that. And then we'll go back to my slides. Whack them all into the thing. So, yeah, playfield load and save. You can do that. I don't care about that. Make a skier. Well, the skier is just like an ordinary sprite, except for the fact that when we update him, we read the keys to see which way he's going to move. Okay? I haven't given these guys a movement speed yet. Maybe I should lob that in. Do you want to see something really cool? Yeah, let's show some cool. Let's make it worthwhile turning up at 5:30 on a Monday. Okay, let's go into my sprite here. Vector 2. This is why we love vectors. Anyone know what a vector is? Hands up those who don't know what a vector is. Okay, as an honest man at the back, that's good. Anyone know how pirates bury their treasure? Arr. Why are pirates called pirates? Because they are. Okay, right, fine. How does this is really going to piss off the people watching the video, but I don't care. When a pirate buries his treasure, he does this. He says, start at the old palm tree and walk ye 20 paces to the right and 40 paces to the down, and ye treasure it be buried here. Right, that's what pirates do when they bury treasure, right? Except this guy's probably west and this guy's probably south, because left and right's a bit on the subjective side, if we're honest. Okay, so that's how pirates bury treasure. That is what a vector is. It tells you how far across to go, and it tells you how far down to go. And that's what a vector is. Is everyone clear what a vector is now? Fantastic. So if you look at the vector type, you'll find that vector just has two members, x and y, which are how far across that vector is and how far down that vector is. And so I can express the speed of my sprite now in a single lump called a vector. And I'll tell you what else I can do, because it's awesome. I can go sprite position plus equals sprite speed. Isn't that good? C# lets you overload operators. Actually, no, I'll make it a little bit. I can do that. That's the same thing, but a bit longer. Take the speed, add it to the position, and that's the new one. I can do maths with vectors. I can add them together. So that means that now I don't have to bother with x's and y's. I can do it all in vectors, which is really sweet. And here I'll pull out the actual vector values and I'll slap them in the appropriate place. So is everybody kind of okay now? So I've now got speed in my sprite, which is good. At the moment, the speed starts up to 0 because none of my sprites are actually moving, but that's fine. What I could do now is, assuming that that's how the update works, let's make ourselves, I don't know, let's make ourselves a ball that falls. Let's make ourselves a flag. So I go class flag is based on sprite, and it does everything which sprite does. I have to give it a constructor. Why? Why does flag have to have a constructor? Because the parent does, and we have to call the parent first. So now I go public flag, and it needs all this guff, so I better go and get all this stuff. No, wrong one. Dilly-dee, up here. Sometimes constructors are a real pain, but there you go. So I go get that, and then I go up here, and I make myself my constructor here. How am I doing for time? Still good. And then once I've done that, I call the base, and I feed it the texture, the rectangle, and the position, and then I don't do anything else because that's good enough for me, and that will shut everybody. And I can make flags now. Yay, go me. Right, so what does the flag do? What does the flag do? When it's moving, what does the flag do? What does the flag do when it's moving? Where does it go? Goes up? You would have a second guess. Down. Thank you. So that means that I want the flag to go down. Well, that's fine. We'll give him a speed that makes him go down. Well, so when let's make a couple of tiny changes. Let's give these guys a velocity as well when we create them. You okay with that? Everyone's muttering amongst themselves. Is this bad? Let's give him speed. And then let's put the speed in here. And then having done that, I then have to pass this guy through as well. So I have to put speed in for flag, which is a bit annoying, but there you go. And then in here I can just put speed in, we're all good. And so now I can drift down into my program, and I can make myself some flags now. So I can go flag. Flag equals new flag. And let's give him a speed going down the screen. So new vector 2. Now nothing across, and maybe 1 going down. Okay. So I made myself a flag. Oh, flags. Yeah, okay. We don't know about flag, do we? Okay, so if I go make a flag, set it up, add it to the playfield, make it run. What will happen now? Well, I'll show you what happens now. Nothing. That's boring. Why isn't that working? Why isn't it moving? Ooh. Because update's not updating. Yes, he is. Okay, run it again and put breakpoints in and have a look. According to my theory, oh, I know why, because I'm a fool. Because I'm a fool. Yes. Because I'm not calling the update, am I? Yeah. I have to steal this code here. Steal that. Go up into update, which is at the moment doing not a lot. Where is he? There he is. Paste that. Call update. So now, give it the game to fiddle with. Now we run it. Yeah, what's going to happen when they reach the end of the screen? They're going to travel through the floor towards Australia. Okay, not great. How do I fix that? How do I fix that?
If it's the end of the window, change the screen.
Yeah, I happen to know. Let's work on the basis. This is probably wrong, but we're not. This is experimental coding. I like doing this. Go back to my flag. Here he is. Give him an update behavior. Override update. Okay. Yep. I'm okay to call the base. If sprite position dot y is greater than, ooh, how big's the screen? Do we know? 800 by 600? Let's try 600. Dot y equals 0. It might not be 600, I don't really care. It'll do something. It's exciting, isn't it? Maybe so I can go a bit faster this time. Yeah, maybe it's bigger than 600. No, it's bigger. And then out it comes again. Okay, you see that? That's how your flags work. Okay, they come rattling down the screen. I want to speed it up a bit, so we'll speed it up a bit. So I go into here and I set things up so that the update behavior, when I create the guy, let's make him move down with a bit more verve than that. Let's make that 4. And then run it again. Whee! And that's a bit better. There's 100 of them, so that's fair. And off it goes. So, if I space those out a bit more, and I had 2 of them, we wouldn't be far off a bunch of flags, correct? Right, let me show you how long have we got? Oh, 10 minutes, that's fine. No worries. How do you make it actually do the wiggly thing? Any ideas? Robert likes sine waves. So what I'll do is, inside the game, make a variable called ticks, okay? Don't know why. Capital T because he's public. Shh. I can't hear myself make it up as I go along. Each time we call update, ticks is made 1 bigger. Plus 1. Okay? Right with that? So I'm keeping count of how many ticks I've had. Fine, okay. Right, so now let's go in here and inside the update for my flag, if I put him back on the screen, I set his y value to 0, which is fine. But what I also do is I set his x value dot x equals game, get the ticks value out of the game, dot ticks, okay, take the sine of that to get me a sine wave, and then, I don't know, multiply that by 100. 20, let's try 20. This is where you play with numbers and see what happens. So each time I put them back at the top, I'll get, oh, you don't like that? Why don't you like that? That's double, that's why. Okay, so I have to make you into a float. That's it. So, each time we get a new sprite at the top, we use the sine wave thingy to place him somewhere. Let's see how that looks. Might look rubbish, I don't know, never tried this. That's not working, it's not going very well, is it, actually? Thinking about it. What do I have to do to fix it? Well, don't really know. Have to have a think. Why is it, if I do this, so I go mass.sine aim.ticks over a, no, that's not going to work. So first time round, it's going to be Oh, several hundred, isn't it? Dunno. Let's try dividing it by 100, seeing as that improves things. No, that's broken it completely. We won't do that one. So let's not do that. Let's make this multiplied by 200. See what that does. I love doing this. This is great fun. Okay, well, we're getting there. So, okay, so my amplitude's about right, but let's do both. At some point we'll get a nice sine wave. I could sit down with a piece of paper and work it all out, but quite frankly I can't be bothered. Okay, that's a bit on the slow side. But it's gone completely now. Okay, fair enough. Well, we'll back away from that a little bit. But can you see what I'm doing? At some point I'll get a nice sine wave, if I can be bothered to think about it properly, and I get myself a nice sine wave. The sine goes between 0 and 1. Okay, but I'm just fiddling with numbers here. At some point a lovely sine wave will drop out. What I could have done is practice this beforehand. No, that's no good. That's no good. That's still no good. Actually, it would be good if I had more. Let's do something really stupid. Yeah, I know what I'm doing. I know what I need to do. Watch carefully, you'll like this. Go to load content. Add one character. That's better, isn't it? Is the other going to come back? I don't know. But it is better. That's kind of, you could see how that would kind of work. Fiddle with the numbers, you might get somewhere. Getting exciting. What I should probably do actually is do this. No, I'll leave it. I've played enough. That's enough. You've seen enough. Cheese and Snowball are just sprites you put on the screen. Create the flags. Here we've done that. Sort of. And it sort of worked. Create the game behavior. Now, this is something which is kind of important. I've got this structure in my code which you'll do a lot of, which is where I spin through all the sprites looking for something. Now remember, you can have the same object in several lists. So I could make a list of all my flags as well as a list of all my playfield. And to see if the player has collided with any of the sprites, you actually have to work through that list and check every one in turn. So you'll take your player and you'll spin through your list of flag sprites looking for intersections between the two rectangles. You have to do all of them. And when it hits an intersect, that means the player has lost a life. There's a slight issue which we may want to think about, because some people already have, and it's rather pleasing. If I collide with something, I might still be colliding with that something next time round in update because I haven't moved away fast enough. So if I crash into a flag, it's kind of important that I don't crash into it again, because otherwise you hit one flag and you lose the game. You're out straight away. There's several ways you can fix that. You could make the player invulnerable for half a second after they hit a flag. Alternatively, you could move the player so that he isn't touching the flag if he collides. And the third way, which I quite like, is you can say, I can only collide with one flag once. So if I hit this flag, I hit it again, I ignore that. So you can keep track of which flag you last hit, and then only respond if you hit a different one that time. But the fundamental behaviour that drives it is spinning through a list of the things you think you might have collided with, and actually dealing with those. In terms of the game, I'm a big fan of enums and state machines, so your game will have effectively a gameplay state, a game over state, and a whatnot. But you did that with Pong, did you not? So lift the code across. One of the labs that you did was with Pong, and that was stateful, correct? You remember? Yeah, I think it was. I seem to remember writing that bit in. This is a bit of a rehash on how I would do my sprites. There's a method in there you haven't seen before called reset. I give my sprites a reset behavior as well, so that actually I can put them back how they should be at the start of the game, because you'll need that behavior when the new game begins. You don't want to make all the sprites again by hand. That's the update behavior. Saving and loading. Oh, I've even given you width and height. Oh, that's generous of me. You might not need those. You can certainly put out the X and the Y, but in fact I'd probably send out the vector values instead, because that's how I roll. There's my game state. There's how I set it. And this is how you use it. So in the update behavior or the draw behavior, it doesn't matter which, you can put a case like this. And the case basically determines which mode it's in and picks the behavior. You wouldn't have the word break, you'd have a call there to a method that did whatever it does when it's game over. Does that make sense? Okay. Attract mode. In attract mode you could randomly drive the player around the place, or generally just have a bunch of flags spinning past. When they press the key to start the game, it flips from attract mode into gameplay mode, and then away you go from there. That's the wrong slide, I apologise. I'll take that out. The end of the game, you want a game over screen, and if you want to do timing in the game, it goes at 60 Hertz, which means that effectively you can count up to 300, that's 5 seconds. So just do that, have a counter which counts up in that state until it reaches 500, goes around, sorry, 300 each time, and then away you go. Keep it small and simple. Don't try and add things before you've made something work. And if you do get stuck, yeah, come and see me and ask me not, I can't do anything, what do I do, but how do I make this particular piece work? Has that been kind of useful? Well, okay, I wasted my time then, fair enough. Any questions? Yeah?
Yeah, attract mode. Say you've got the title screen, like new game, load game, options, whatever, and it's running in the background. Does that count as attract mode, or does it have to be a separate mode when you click it, it runs the game on the time?
Have you got, you have like a menu screen at the start, which actually lets you pick what you want to do.
Yeah.
How do you pick things from the menu?
I haven't done that yet, but you just select, you either click on it or...
Okay. Okay, I mean, a menu screen will kind of compensate for an attract mode, I guess. But as long as your game has got different states, that's what I'm really after. I want to have a state where you're playing the game, a state where you've finished the game, and an attract state or menu state where you're not doing either of those two things. Does that make sense?
Yeah.
Any other questions? Okay. In that case then, we'll move on.